Good morning. Thanks so much for joining us here today. Hopefully most of you had a chance to hear a little bit about Lambda in Werner's keynote earlier this morning. And in this session, we're going to be talking about how we developed this service in the first place, some of the things that we think people are going to use it for, and then a little bit about how you actually use Lambda. So let's talk a little bit about the motivations here. And I want to begin with a couple of simple problems. So first, imagine that you want to upload some images, maybe from a mobile app or a web app, to your S3 bucket. And then once they're there, you'd like to turn them into thumbnails, or maybe do some other kind of image conversion. Very simple problem. Another simple problem, imagine that you've got a DynamoDB table. You've got addresses stored in the table, and you'd like to verify that each of those addresses is well-formed. It may be corrected if it's not. Easy to describe, probably not very much code for either one of these problems. But what does it take to actually implement them? Well, it turns out the solution's actually a little more complicated. Even with all the great building blocks that AWS provides, there's still a lot that you've got to do. Turning those few lines of code into a highly available, highly reliable, highly scalable, and very secure web service takes a lot of work. You've got to go provision some machines to be able to capture those incoming requests. You need some kind of durable queue to be able to store the jobs that you're going to need to do, such as those image transforms. You're going to need some more machines to actually go do the image transforms. And then with all these machines, you've got to get code deployed onto them, not just once, but many times. You need to figure out how many machines you need, how much capacity, how bursty will your workloads be. Are you sure you've got enough, but not too much? And then you need to build in a bunch of things which aren't directly related to your business logic, but are still super important. The monitoring piece, the logging piece. And then once you've got all of that, on day one, you've got to worry about the future. How do you migrate this going forward? How do you do security patching? How do you keep all of this up to date? What happens when hardware types change? What if there were a better way? What we challenged ourselves to think about was a mechanism by which we could take use cases like this and provide a much simpler solution. One where you could tie the code to the data as it enters the cloud or as it passes through the cloud. And so one of the key ideas we had was, what if every service in AWS could generate events, could tell you when it's done something interesting? Maybe an API has been called, or an object has gone through some kind of transition. So if you think about S3 as an example, you start by putting an object the first time, that's a creation event. Then you copy the object, perhaps, that's a copy event. Then you do some updates to the object, delete the object. Each one of these transitions is a different kind of event. But having events themselves isn't enough. You need a way to respond to those events that's super easy, in a way that matches the complexity of the solution to the complexity of the code that you're trying to deploy. So it's got to be easy to author, it's got to be easy to maintain, it's got to be easy to manage, it's got to be easy to scale. Right? This is where a full stack solution is so complicated, because if you've got 10 lines of code, right, deploying a full stack solution for that just doesn't feel like the right answer. It's an impedance mismatch to the size and scope of the actual problem. So instead, our answer to this is what we call event-driven compute. It's all about taking stateless, request-driven code that we call Lambda functions, and then triggering those Lambda functions on all of these different events. So as something happens in an AWS service, you can have a trigger or an event handler that goes and takes action to respond to that. And that action can be anything you want. It's just code. You can call other AWS services. You can call other web services. So now you can take something like a put to an S3 bucket, a write to a Dynamo table, maybe a lifecycle transition in EC2, messages that get entered into a queue, or data that's passing through, like clickstream data passing through a Kinesis stream. And you can turn all of those things, in fact, any API or resource transition eventually, into a code execution. With this, AWS Lambda becomes the connective tissue for all of AWS, the thing that lets you turn these API calls or resource changes into code responses. So what could we do with this if we had it? Well, we've already talked about one interesting use case here. We can build data triggers. We can take things like uploads of images as they pass into an S3 bucket and then build automatic responses to them. So Lambda can take those images and with a few lines of code, create a thumbnail and put it back into the same bucket or into a different bucket. In fact, we'll take a look at that in the demo here in a few minutes. Another example, data that you put into a DynamoDB table can generate change events. So earlier this week, we announced a limited preview of a new Dynamo feature called streams. Streams are delta events. They tell you what happened to a table by showing you either the new data, the old data, or both of them as that data is changing in the table. Now you can use this feature for lots of different things, but one really interesting thing you can do with it is to hook it up to a Lambda function. So now as you put data into your Dynamo table, you can respond to those changes. You can check an address. You can correct an address. You can make copies to another table, and not just blind copies, but filtered or transformed copies. Or you can detect data that maybe is anomalous or out of bounds and send yourself a notification. To expand a little bit on that notification one, we think there's a whole range of really interesting auditing cases here as well. So if you're already familiar with AWS CloudTrail, you know that we have a mechanism in AWS, a service that for any API call across the whole range of AWS services can generate a log file in S3 to tell you who's been calling what and who's been doing what with your resources. That's a super powerful service already, but because it drops that file into S3, now you can hook up Lambda and you can very quickly build an auditing solution that looks at the records in that audit log and decides what to do with them. Which ones are important, which ones aren't important, which ones to keep, or if something looks really bad, maybe which ones to wake you up in the middle of the night for. And while I describe this here in terms of CloudTrail, there's nothing special about the fact that they generated the log. Any log generated by any source in S3 could do the same thing. And finally, there's nothing magic about the fact that other AWS services are generating these events. The API on Lambda that accepts those events is just triggering a batch computation. It can take custom events from any of your applications as well. So if you have a mobile application, tablet application, web app, other web service, you can call into Lambda's public API, pass it an event as JSON, and get it to kick off an event processing just as if it were coming from another AWS service. So, some interesting use cases here. What does it take to make those use cases really soar? How would we have to style this in a way that would make it really effective? Well, when we thought about the requirements for Lambda, the first one we started with was the infrastructure challenge. Because if you think of that long laundry list I gave you at the beginning, we've got to get rid of all of those different steps, or we're not going to be able to make this simple enough to have maybe as little as one line of code turned into a service and do so easily and quickly. So in order to let you focus on the business logic, Lambda has to take on the other responsibilities: handling capacity, scaling, deployment of your code, fault tolerance, monitoring, logging. All of these things are built into Lambda so that you don't have to worry about them anymore. Now, the other piece that's really important to get right here is automatic scaling. And this has to do with the way Lambda works. So instead of renting compute capacity and installing your own applications on it, you give us code and then you tell us when to run the code. So Lambda's request model looks a lot like S3 or Dynamo's request model. Only instead of saying, hey, please upload my code, or please get me an object that I've previously stored, with Lambda you're saying, please run my code now. It's time to go do something. Here's an event. Let's go process it. So in order to make that work right, we need to be able to match the rate of changes that are happening in, say, an S3 bucket or a Dynamo table with the rate of invocation of the Lambda functions. So as you start doing more and more puts in the table, more and more parallel Lambda functions start getting fired off. If you throttle them back, you make fewer and fewer requests. And the nice thing about that is you don't have to worry about over or under provisioning. Just as if you're using an S3 API, right, you never worry about whether or not there's too much or too little disk capacity in S3. You just make the request you want and you trust that service to do the right thing with them. And of course, that also means that you get a very micro version of pay for use, because we only do work on your behalf when you actually give us a request. BYOC, bring your own code. So obviously Lambda is a different kind of paradigm, and I want to be really clear that this is not about taking an existing web app and running it in a different way. EC2 is a great existing solution for that. We have Beanstalk and lots of other mechanisms that work really well for that today. But if you want to run some Node.js code, which is the language we support at launch, you want to be able to do so in a way that doesn't provide lock-in and gives you lots of flexibility. So for example, you want to be able to create threads and processes. You don't want to get locked into some strange programming model that doesn't feel natural. You want to be able to use libraries that might have to write data to /temp, and in fact, we'll do that in the demo in a few seconds here. And you want to be able to bring your libraries with you. And so one of the design requirements that we set at the very beginning of the Lambda project was to say that you have to be able to bring any library you want, not just native JavaScript libraries in the Node.js case, but any native library whatsoever. And then finally, to make all of this work, the pricing has to match the scale of the functions. So if you have a function that only runs for a few hundred milliseconds to thumbnail an image, you don't want to be charged for a minute or an hour of compute time. And as a result, we've set the pricing in a very granular way so that every 100 milliseconds is the granularity that we've chosen here, so that it's a nice match to the size of the functions and the amount of work that they're doing. So let me just take a second here and kind of do a quick compare and contrast, because one of the questions I get asked a lot is, how is this different than what you've got today? What's different about Lambda? So quick summary here. As I said, Lambda is request-driven as opposed to an infrastructure rental. So you tell us when you want work to get done, you call into the APIs, or more frequently, you do something with another AWS service that triggers the APIs to run. Lambda was designed with the perspective of trying to be making it easy to use. Right? It's designed with productivity in mind. So it has a fixed operating system, has a fixed language. We let you bring your own libraries, of course, but we try to make it a very simple system to get started. I contrast that with EC2, where there are a whole lot of different workloads. Some workloads that require different types of hardware, workloads that require different operating systems. And so if you have that kind of flexibility need, EC2 is the right answer. But if you just have some code you want to run and you're relatively indifferent to things like, exactly which Linux am I running on, then Lambda makes it really easy to get that job done. With EC2, you own and manage the infrastructure you rent. With Lambda, we own and manage the infrastructure. So that's the way that we make it possible to take a lot of that burden away from the developer. And then, of course, the scaling model, as I mentioned with Lambda, rather than scaling by specific instances, you just scale by making requests. It's an implicit scaling system in that you ask for the work you want to get done, and behind the scenes, we take care of things like figuring out how much compute capacity you need and where to land those requests within it. All right, let's move on here and talk a little bit about how you actually use Lambda. So what does it feel like to a developer? Well, we'll start with the obvious here, like writing the code. We're launching with Node.js support. We'll be adding more languages down the line. Built into this is the AWS SDK. So while you're not required to use other AWS services in order to use Lambda, one of the things that we wanted to make really easy was setting up and pre-credentialing your ability to call any other AWS service. So by including the SDK and getting it all set up, we made it really simple for you to just get started. All you have to do is begin calling, say, S3 or Dynamo or whatever APIs you want to use. And then for convenience, we've actually included a graphics library as well, ImageMagick, but we've done that purely for convenience. You don't like the version that we included, more than welcome to bring your own. You can even bring a different copy of ImageMagick if you want to compile it with different flags than what we've chosen. Now, the programming model has one interesting difference than what you might be used to in EC2, and that's that these Lambda functions are stateless. And what we mean by that is that if you've got persistent data, you can't store it locally within the function, because there's no guarantee that your function is going to be run on the same piece of infrastructure from invocation to invocation. Different requests might land on different pieces of infrastructure, either because you're running them in parallel or because we've changed the infrastructure over time. So if you've got data that you want to store or data that you want to read, you need to put it in S3, Dynamo, or some other kind of internet available storage device so that you can retrieve that data when you want it. Apart from that, we've tried very hard to make this a familiar model. So you can use things like processes and threads. You can write data to /temp. Data won't be there forever, but you can write it there while you're executing. bring your own libraries, and there are a very small number of restrictions that we put in place from the sandbox. So we tried really hard not to let the complexity of providing a very secure and isolated model show through into the programming. So we put only a few restrictions, things like not allowing you to do inbound socket connections because we're doing the web service front end for you. All right, once you've written some code, what do you do with it? Well, configuring Lambda functions is really straightforward. We'll show you how that works. Pick a name for your function. That's how we identify them. Pick a size. And by size, we mean picking a memory size. So you can set it anywhere from 128 to a gigabyte in steps of 64 meg. Now, while we ask you for it in terms of memory, what we're really doing here is sizing all of the resources for you at once. So if you ask for, say, 512 versus 256, you get roughly twice the compute power along with twice the memory. This gives you a simple single dial by which you can tune your price-performance ratio. Now, one of the questions that people have is, well, how do I know? Like, what if I use too much or too little memory? So we provide monitoring so you can see things like error rates in case you've provided too little memory and maybe you're having challenges there or your latency is getting high. We also stamp into every log result for every function that executes how much memory you had requested for it and how much you actually used, so that it's really easy for you to go in there and see, hey, maybe I've allocated too much and I can turn it down and save myself some money. And then once you pick the name and pick the size, you have the option to pick an event source. So if you're doing custom events, you might stop after the first two. If you want to hook this Lambda function up to S3, to Dynamo, to a Kinesis stream, then you're going to go configure the association between the function and the AWS service that's generating those events. So, wiring up events. AWS services send these events or have these events retrieved from them in the form of JSON. And in fact, if anybody's looked at the CloudTrail schema in the docs, that's exactly the same thing that we're using now. Like the events that S3 and Dynamo will generate look a whole lot like the records that CloudTrail generates today for API auditing. These events, these JSON payloads, get reliably transmitted between other AWS services and Lambda so that we can provide what we call at least once execution attempts on your code. And you can guarantee, for example, that if you've put an object into S3, that we will, in fact, go and attempt the execution of your Lambda function. Now, what happens if your code is broken, right? We're going to attempt the execution, but there's no guarantee that your code is going to do something useful. It could have a top-level exception. It could go into an infinite loop. So there are two possible answers to that, and we have to talk here a little bit about the implementation specifics. So the first category of events that we've got are from services that we call push services. So the easiest one of those to understand is custom events. Obviously, in that case, your application is pushing that event to Lambda in the form of making an API call. It turns out S3 works the same way. When something happens in an S3 bucket, S3, on your behalf, makes a call to Lambda and says, hey, it's time to go run an event. Here's what just went on in this bucket. Those are processed in an unordered model, very similar to the way SQS queues work today, and we'll make 3 attempts to run your code. So if your code is throwing a top-level exception, you get 2 more tries. At that point, we'll give up. Of course, you can always put handlers in your code to catch that case and decide what you want to do, in fact, if you've got that error. But if you are escaping out or timing out, then we'll make 3 attempts. The other category here are what we call pull sources. So DynamoDB streams and Kinesis streams work a little differently. They have to be polled. And Lambda will do that on your behalf, so you don't have to worry about the details of it. You just tell Lambda which event sources you'd like it to go read for that type of event. But the model is slightly different here. First of all, those are ordered event sources, right? And so it's important that Lambda process those events in the order that they're generated by the event source. We do that so we can preserve the ordering semantics. And as a result, we can't stop attempting to call your code because doing things out of order or giving up might result in an invalid sequence, an invalid semantics. So we'll do some back off, but what we will keep trying in those cases until the data expires, And then it's important for you to monitor error rates and sort of throughput for those sources to make sure that your code's doing what you expect. Alrighty, I'm going to come back to this in a second here and switch over to the other machine. Alrighty. This is the Lambda console. So while you can use the CLI or the SDK, of course, demos are a little easier to drive from here. So let's take a look at what happens when we go to create a Lambda function. We'll see if the demo gods are with me. Alrighty. All right. Let's try creating a new function here called hello-reinvent. So first step, we give it the name. We're going to come down and use the inline editor here. So let me expand this a little bit. And we'll do the kind of classic demo here, console.log, hello world. So the inline editor makes it easy to get started. Of course, you can upload from a zip file as well. But this is an easy way to write your code directly within the browser. Now, we need to give that code a role to tell it what kind of authentication that it has, which kinds of things we want it to be able to do. So I'm going to hop over here to the IAM management console. This will just take a second. I'm still running on a beta version of this, so the interaction's a little slow today. And I'm going to go ahead and give this an execution role and policy that I've already created earlier. And what I just did there was effectively credential my code with the ability to use the things that I wanted to use. In this case, we're doing writing some logs, and so it needs, among other things, the ability to write to the log streams in CloudWatch. I've set the memory and the timeout here earlier. I'm going to go ahead and create this function now without changing those values. And now you can see here, I've been taken to the dashboard. So my hello-reinvent function is here. Not much interesting has happened so far. I haven't had any requests. So from here, I can do a few different things. For example, if I wanted to go wire this up to an S3 bucket, I could go do that right here. Pick a bucket in S3 and say, every time an object is there, please respond to it. Now, we already have one of those set up, so I'm going to go back here and do something else instead. I want to go test this. So I'm going to pick a template here for testing. And what you're looking at here is just essentially a little test-driven version of the event payload that we're going to send. Right? It's just got some dummy values in it. So now we'll go down to my code. Here we have the code that we just created for our cloud function. I'm not going to edit it any further. What I want to do is I want to go run it now. And here we can see we just executed that, pulled back hello world. Not very interesting from a semantics perspective. What's interesting is that we just did what would have taken a lot of work had you had to do it yourself. Provisioning an EC2 instance, deploying that instance, getting your application stack on it, running your code on it, setting up monitoring and logging. That little hello world that just happened in the space of a couple of seconds there did all of that work behind the scenes. And now I'm going to hop over here quickly to the CloudWatch console. And we'll scroll down here and look for our sample. There it is. Oops. Sorry, I got the wrong one here. Let's try hello-reinvent. Here's our log stream. And here we can see that same data that we showed in the results pane in the Lambda console, right, what we brought back was just the log capture from running that. But of course, all the logs are also going to actual CloudWatch logs. So without any work on your part, you get a full logging solution and a full monitoring solution. All of the Lambda dashboard, which we can go back and take a look at here now, is also being mirrored in CloudWatch metrics. So here we can see we had a little spike here because we actually did a little bit of work. And we could hop over to CloudWatch metrics and see those same metrics in detail from the execution of that hello world function. All right, so now we've kind of done a full life cycle here. We've created a function, we tested it, we invoked it, we checked out the logs and the automatic monitoring that we did. Let's go look at something that's a little more interesting. So I have one here which actually is wired up to S3. You can see I've used it a little bit in the past. And we're going to hop into that same edit and test feature so that we can try to have some fun with it. So this code, and I'll scroll down here so you can get a little bit of a sense of it, is an image thumbnailer. And so in, let's see how many lines we've got, 56 lines of code. I've got an image thumbnailer which is reliable, scalable, secure, and connected up to an S3 bucket. So let's go ahead and try executing that. I'm going to use this same template, this time an S3 template instead of a hello world template. And I'm going to go take the mock values that we put in there, and I'm going to trade them out for an actual bucket name and an actual key name. So we'll take a quick look here. Here's the S3 bucket. I've got a couple of files in there. Big fan of squirrels. I've got a pet squirrel at home, so I've got squirrel pictures in my bucket. So now let's see what happens. Fingers crossed. I'm going to press that invoke button again, just like I did for Hello World. Run the code, so behind the scenes, compute infrastructure was found, my code was deployed, the code was run. The log file looks interesting here. Let's hop back to S3 and see what happened. Go refresh, and sure enough, we got a thumbnail here of a squirrel. Let's see if we can check that out. Sometimes my image viewer doesn't like to start here. Gonna get a squirrel? There we go, little squirrel. Sadly, I forgot to upload a picture of my own squirrel, so that's just some random squirrel. All right, so we saw the code running here in the form of a test invoke, and we saw it sort of do something interesting with this S3 bucket. So you saw Lambda doing something in S3. You didn't see it getting triggered from S3. So let's go try that now. So I'm going to upload another file. Here's a squirrel picture we haven't used before. And let me see if I can get this dialog actually high enough up that I can, oops. Apologies here. Let's try that again. Alrighty, I made this small enough we can actually see the buttons. Okay, we got a squirrel picture. We're going to start the upload. Okay, so a new squirrel picture appeared, red squirrel.jpg. Let's go refresh the screen, and now we see thumbnail of red squirrel.jpg. S3, talking to Lambda, behind the scenes, no work that you had to do to make that happen. Alrighty, so a couple of best practices here. One of the things that you saw me do there was create a role for my Lambda function. And there are actually two different roles that are interesting here. There's what we call execution roles, and those control what it is that the Lambda functions can do. So for example, if you're going to read from an S3 bucket and send notifications to SNS, then your execution role has to provide you with the capabilities to read from S3 and to write into SNS. Right? The role has to match the set of activities that you want to do. This gives you fine-grained control, so you can determine exactly what that function is allowed to do. And if you're doing this inside an enterprise, you've got complete control over those policies in the same way that you do for any other invocation of any other API within AWS. So keeps things fully authenticated and fully secured and fully under control of enterprise administrators. Now there's a second role, which we didn't talk about much, and that's called the invocation role. So while execution roles determine what your function can do, invocation roles determine who can call it. So if we think about that S3 case that we just did, I had a whole list of buckets there, and I had a whole list of cloud functions. And so we want to be able to decide which of those buckets get to send events to which of those cloud functions. So I've got bucket A sending to function A, bucket B sending to function B. I might want to make sure that I don't get any crosstalk there, right, between those things. Maybe they're owned by different parts of my organization. So that's where invocation roles come in. While you can set your invocation roles in a very simple way, if you need more complicated setup, they give you this fine-grained control over who can call what. And they work not just for the S3 case, but also for the Dynamo case and all other AWS services. All right, the second thing I want to talk a little bit from a best practices perspective is recursion. So if you were kind of watching carefully there, you noticed something interesting, right? I put objects into an S3 bucket, and they called a Lambda function, which turned around and put objects back into an S3 bucket. So it turns out that in that code there, in my code, I actually put a check to say, hey, if the name starts with thumbnail, then we're done. Don't do any more. Don't create thumbnail of thumbnail and thumbnail of thumbnail of thumbnail. So you've got great power here, right? This is obviously an interesting use case to be able to repurpose the same bucket, even though you could have done it with a different bucket, and in some ways it would have made my demo a little safer this morning. But we wanted to illustrate the fact that there's a lot of flexibility here to put objects wherever you want, to write the code that you want. Of course, just as is the case with your own code in any programming language, right, there's the possibility of creating infinite recursion or infinite loops. Another thing that we didn't show here today in the demo was the ability for Lambda functions to call other Lambda functions. That allows you to do interesting things like get one event from a source, like an S3 bucket or Dynamo, and then actually fork off several different kinds of work so that you can organize your functions in different ways or decide conditionally which ones you want to call. Again, powerful feature, really useful, mimics what you would do in a conventional programming language, of course, just convert it to the cloud execution paradigm here. But again, you want to be careful because, of course, if those functions call themselves, then you will be sitting there in a loop generating requests over and over again. And you can use monitoring, you can use logs, all the typical ways to define that. But we felt that it was important to give people this power rather than artificially limiting what it is they can do. All right, so we talked a lot about what Lambda is, a lot about the things that we think people are going to want to do with it. How do you actually get started with doing something? So what we're announcing today is the AWS Lambda Preview. Lambda launching in preview includes support for Amazon S3 event notifications, which are also being announced today. And there'll be a talk later this afternoon if you want to hear more about that feature. It's capable of sending events to Lambda as well as SNS and SQS. It includes support for DynamoDB streams. Those are also in limited preview. And so if you're interested in trying the combination of both, you'll need to join the limited preview for Dynamo streams as well as the Lambda preview. And we also include support for Amazon Kinesis streams. So if you want to be able to trigger, transform, or operate on stream data, you've got that built in as well. The console I showed today, along with the SDK and the CLI, is included in the preview, so you've got full functionality. What we limit during the preview is basically capacity. So to ensure that we've got capacity for all the people who want to try it out, we're initially launching with a limit of 25 concurrent requests per account, and a limit of 60 seconds of runtime for each request. And expected in the future, we will lift both of these limits higher. To get started, go to aws.amazon.com/lambda. You can sign up for the preview, and we'll be letting people in as quickly as we can after that. Right. And with that, I think we have time for a few questions here if anybody wants to ask them in the room. Sure.
Can you disclose a little bit about how you implement Lambda, what services you leverage, and if you use it for campaigns?
Good questions. So a couple of interesting topics in there. Unsurprisingly, sorry. So question included a little bit about how we built Lambda. Are we using Docker containers? And maybe more broadly, kind of what's the relationship of this to some of the other technologies that you're hearing here today? So, of course, we're using the same reliable infrastructure that EC2 uses to provide our capacity and also to provide some of the security apparatus that helps us ensure that we've got strong isolation between customer accounts. So the same kinds of security and operational fortitude that people have known and trusted on EC2 is also built right into the Lambda infrastructure. Now, we do use Linux containers as part of our implementation. We don't rely exclusively on Linux containers for any of our security or isolation, because we felt that it was important to actually couple that to a range of technologies. If you heard this morning about the container service that's coming out, one of the things you should expect us to do is create joint possibilities for using both of those things over time. Thanks. Sure.
Is there a way to stop the runaway execution if you do get into inadvertently get into recursion?
Yeah. So let's suppose that you've got a runaway execution. What are your choices here in terms of fixing that? Well, one of the things you saw me do here was edit the code live, and so it's easy enough to come in there and simply terminate the code or effectively put it into a disabled state simply by editing the implementation. If you want to do something more hardcore, while I didn't illustrate it here today, you can also delete a cloud function and then go recreate it later on. So that's kind of your instant kill switch, if you like. Sure. Sorry. Yeah, so the question was, what functionality can you access from the underlying operating system? So we built this on top of Amazon Linux, and from within Node.js, you're basically welcome to use most of the operating system functionality. So we give you a restricted file system view, obviously, in which you're running. But you've got a broad set of capabilities even within that. So as I mentioned, for instance, you can go fire up a bash script if you want. So there's a lot of flexibility there. Almost all of the operating system primitives are available to you. We restrict a few things like inbound network connections, UDP type sockets, and a couple of system calls.
With no software installation?
No software installation other than implicitly what you bring in your zip file with you. Sure. And sorry, I know I almost had you there.
So I guess the question I had was latency from the time the event is produced.
Is there any data on the latency from the event being produced to when it starts processing?
Yeah, so latency, that's a great question. Let's talk about that. Our goal in Lambda is to start executing your code within milliseconds of the arrival time. So typical latencies, I mean, hopefully you got a sense of seeing this up here, right, is a sub-second. Now, it depends a little bit on what the event source is as well, because the real answer to your question is not just how fast is Lambda, but also how does it work when you've connected it up to a different data source. And the periodicity and the latency of something like Dynamo streams is a little bit different than what Amazon S3 buckets are, which is, again, maybe a little different from the way Kinesis streams work. So the real answer there, to be sort of complete about it, is that you've got to add the latency of whatever the event source is to the latency of Lambda itself. But we goal ourselves to have on the order of 100 milliseconds or less transit time between the event arriving or the event being polled and the time when we actually start your code. That'll be a little higher on the first use. Obviously, if we need to go fetch your code because we've never seen it before or because you haven't been around for a few months, then there's a higher latency there as we go grab your code and get it running again. Sure. So, sorry.
So do you have any plans to go beyond editing your functions in the web view or zip files as far as like version control, Git integration or anything like that?
Yeah. The the desire here is always to try to find a balance between, you know, a minimum viable product, getting things out early into people's hands, and building a sufficiently complete, a complete solution that's got all the things that you really wanted to have. So we had some painful cuts here, of course. I would have loved more deployment options at launch. That's high on our list, as is adding more languages here. And you should expect that we'll, you know, obviously we want to hear feedback about that to help us develop those priorities, but that's certainly on our, you know, on our list to execute on.
Can you describe what it looks like for the native library stuff? Like, do we include a script or, you know, a build script or what?
Yeah, sure. So you bring your native library in the form of basically put it in Node clothing, right? So if you can expose it to Node.js, then you can call it from there and execute it. Yeah, yep. So one of the things we'll be working on, we don't have it ready today, but we'll be doing a blog on how do I build myself a custom library and call it from inside a Lambda function.
When do you expect it will go into general availability? When can we start building production on top of that?
Early in, in case everybody didn't hear, like when will we move into general availability? Our plan for that is early 2015.
So you mentioned at least once semantics. So is it the same as SQS where you potentially could have the same event trigger the function twice?
Yeah, so a great way to think about the way that the S3 interaction or custom events work is to imagine an SQS queue sitting at the front end of Lambda. So those events come into a queue, the queue provides durability, but it also has an impact on the semantics of how those events get processed. So in this case, that means that those events occasionally may come out of order or may occasionally be presented twice. Sorry, folks, I'm following the microphone here, just so we can hear the questions.
What's the roadmap around adding integration with other AWS services like RDS?
Yeah, so you should expect us to be working aggressively to add support for additional services here. We've heard requests for EC2 come up a lot. RDS is obviously another one. So I don't have a roadmap to share with you here today. I'd love some feedback if people have it on that.
What about the eventual consistency of S3 in the US East 1 region?
Eventual consistency. Yeah, so one of the reasons that we put the multiple retry logic in was precisely to give your code some time in case you're hitting an eventual consistency issue. That's one of the reasons to actually spread that out a little bit and allow time for stability in the case of write stabilization.
Is there any support for timed events, something that'll trigger at the same time every day?
Yeah, that's it's a request that I've heard a lot already. So you know, I guess the unsatisfying answer is, of course, you're welcome to run a timer somewhere, or you can, you know, use SWF if you'd like to generate sort of events out of there. What we'd like to do is, in the same way that we made the infrastructure simple, we'd like to make the timing and initialization simple. And so you should expect it in the future as we move forward. That's one of the things that's on our list.
Will you be able to? Will you be able to hook up other non-AWS stuff for your pull interface?
Sorry, could you repeat the question?
Can you hook up other like your own services to the pull interface?
To the pull interface, not to the pull interface today. We have actually done a hard-coded polling system essentially to the internal services that we know operate that way. One of the ways that you can accomplish that, though, is if you can use Kinesis as an intermediary. Since it's a low-cost, sharded, ordered event model, it forms a great capacitance in transit between other services.
So we'll take one last question, and then Tim will be around.
We're getting low on time. Thanks.
Also, there will be a repeat session at 11 a.m. tomorrow, so please be there if you have any other questions.
So with the NPM libraries that you can install, could you potentially install like the AWS NPM library and integrate through that? And what kind of network access do these scripted instances have? Could you stream a file from it? Is it you know, like what sort of limits are there on your network access while this Node.js script is running?
Yeah, so for outbound connections, we basically what you can do with TCP/IP sockets, you can do from within a Lambda routine. So we don't put restrictions on what you can do at that level. Now, during the preview, the duration of execution at 60 seconds would obviously limit some of the things you couldn't do, you know, interesting movie transcoding with this, you know, with the limits we've got in place today. And that might not be the best or most obvious use case anyway for Lambda, but yeah, if you can do it with a TCP/IP socket, then you have access to that.
Use the AWS library to access MBL2, to access, you know, Elastic Transcoder or any other things that we have on cloud and integrate that way?
Yeah, so the question is, can we use the AWS SDK libraries? Yeah, and it may have been gone by too fast or been too small to see, but what I was doing with the image here today was the AWS SDK JavaScript library, and I was using that to make the S3 calls. All right, I think we're out of time here. Thanks so much, everyone.